All right, guys, so we have been working on in class solving radical equations. So I'm going to kind of go over it with you and then have you do a worksheet that you'll submit to me. And that will cover your week's work, like what we're doing in class. So that will be like an alternate assignment for you guys, okay? All right, so solving radical equations. Here are our 3 steps. So first we want to isolate the radical, meaning get it all by itself on one side of the equal sign. Then we square each side in order to get rid of your radical, and then you just solve the basic equation. Okay, so I think it's just easier if I go through examples. All right, so for this first one, I see that I have, this is being multiplied, this 5 is being multiplied. So again, I'm trying to isolate this right here. I want to get it all by itself. So I'm going to divide both sides by 5. When I do that, the only thing that happens here is that these two divide. It does not affect anything under the radical. Leave that alone. Don't divide any of that by 5. So then we have the square root of 3r minus 2. 20 divided by 5 equals 4. Now that the radical is all by itself, we're going to do step 2. So we're going to square each side. So square and square. So this square root and this square cancel each other out. So we have 3r minus 2. So notice when we square this, it does not affect anything under the radical. Whatever's under the radical just stays. Don't change that. 4 squared gives me 16. So now we just have a basic 2-step equation. So I'm going to add 2 to both sides. So 3r equals 18, and then divide by 3. So r equals 6. And then of course I can always go back and I can plug my answer back in for my r and make sure it works. So 3 times 6 is 18, minus 2 is 16, square root of 16 is 4, 4 times 5 is 20. Okay, so you can always go back and check your work. All right, for this next one, so now I see that here's my radical, right? I need to get rid of all of this. So I'm subtracting 1. So in order to move this, I'm going to add 1 to both sides. So then I have 7 equals the square root of 6x minus 5. Again, adding 1 does not affect anything under the radical. Then we're going to do step 2, square each side. So square and square, so we have 49 equals 6x minus 5. Again, the square and square root cancel each other out. It does not affect anything under the radical. So then I add 5 to both sides. So 54 equals 6x, and then divide by 6, and x equals 9. Okay? All right, just a couple more examples. All right, so this next one, so again, I see this -3 is being added, right? So I need to do the opposite of this. Instead of taking -3 plus, I need to subtract a -3, which is actually just adding 3. So again, we're just looking at this, right? So we add 3 to both sides. So then we have the square root of 110 minus 2x equals, 10, not 9. Now we're going to square both sides. So the square root and square cancel each other out. So now I have 110 minus 2x equals 100. I'm trying to get x by itself, so I got to get rid of this 110. So subtract 110 from both sides. -2x equals -10. Divide by -2, and x equals a +5. Again, substitute it back in, check to make sure that it works. Okay, the other way we can see this is if we have a radical equals a radical. If here you see we had some stuff with a radical equals a number. So when we have a radical equals a radical, the first step, our radicals are already isolated on each side. I don't have a +2, a -5, or anything on either side. So I'm just going to jump straight to step 2. And I'm going to square both sides. So then I have 2b minus 8 equals 3b minus 16. Again, when you square with a square root, those just cancel. It does not affect anything that's under your radical. So now it's just a matter of getting my b's together. So I'm going to subtract 2b from both sides. So those cancel. I get -8 equals b minus 16. Then I'm going to add 16. Again, I'm trying to get b by itself. -8 plus 16 gives me 8 equals b. Okay. Another example. Again, radical equals a radical, so I'm going to square both sides first. So then I have 21 minus 2m equals 3m minus 14. I'm trying to get the m's on the same side. So add 2m to both sides. So 21 equals 5m minus 14. Add 14. Again, this is just your basic equation stuff that you learned back in middle school. So 35 equals 5m. Divide by 5, and we get m equals 7. Okay? All right, one more, just because this one's a little different. So this one, again, radical equals a radical. So square it. So I have k over 7 equals 2k minus 91. So I need to get this k by itself. So I got to get rid of this divide by 7. So to do that, I'm going to multiply both sides by 7. So then those cancel, so I have k equals. Now, when I'm multiplying this by 7, I actually have to distribute that 7 to both things on the inside. So 7 times 2k gives me 14k. 91 times 7 is going to give me 637. All right, so now I notice I have a k here and I have a k on this side. So I got to get these k's together. So I'm going to move this 14k over here with this k. So subtract 14k from both sides. If you remember Mr. Likens, like he always had you do the upside down t, so that's kind of what I'm meaning by sides there. So then I have negative 13k equals negative 637. Divide by negative 13, and you get k equals 49. Okay? So that's all this is basically isolating your radical, square each side, and then solve the equation. It's pretty basic. These can get more complicated, but we're going to stick to basic. If you need to, rewatch the video, rewind it, pause it, kind of look at them, and see what you can do. If you have questions, please feel free to ask. Thanks, guys.